organizing data. Organizing data. It's very important for us to know that when a researcher goes in the field, he collects data, and this data is most likely to be unorganized and somewhat overwhelming. Now, this data that has been collected is not suitable, is unsuitable for interpretation because it's not organized in any way. So the researcher needs now to put this data in order for it to have any meaning. At this stage, this data that is unorganized, we call it raw data. This data must be processed in order for it to have meaning out of it. And the primary stage of processing the data is organizing this data in order for it to have any meaning that can make sense to a researcher. There are several methods of processing data or organizing data to have its meaning. And some of these processes that are given in statistics are there to organize this data so that when we look at the data has a meaning. And in statistics, that organization refers to the process of structuring and arranging data for statistical analysis. So when we are talking about data organization, we are simply referring to the process of restructuring and arranging data for statistical analysis. This involves preparing the data in a format that facilitates the application of statistical techniques to extract meaningful insights and draw conclusions out of the data. Now, what are some of things that are done when we do the data organization? The first one is data cleaning. Before analysis, it is essential to clean the data by identifying and handling missing values, outliers, inconsistencies, and errors. This ensures the accuracy and reliability of the statistical data analysis. The second thing we do is data coding. Categorical variables need to be coded numerically to be processed by statistical algorithms. For example, we assign values to categories such data such as male and female. So you will get us assigning male to take a value equal to 1 and female taking a value equal to 2. That's what we call coding. And there are several other ways in which we can do the coding of the data. Number 3, data transformation. In some cases, the data needs to be transformed to meet the assumption of statistical tests or to improve the distribution properties of the variables. So when we transform the data, we are only trying to help so that this data might meet the assumption of statistical tests. And when we'll be doing these tests, we will see these assumptions that are in each test we use in statistics. Also, another thing we do in organizing data, it is variable selection. Depending on the research question and the statistical analysis objective, variable may need to be selected or excluded from the data set. This process involves considering factors such as relevance, correlation with other variables, and the potential multicollinearity. We will come to multicollinearity when we'll be dealing with some of the statistical techniques or tests such as multiple linear regression, because this one affects the data at that particular stage. Also, data structuring is another point we consider when we are doing organizing of the data. Data should be organized in a structured format, such as a table, or a spreadsheet, with each column representing a variable and each row representing an observation or a case. This tabular structure allows statistical software to analyze the data effectively. Also, when we are doing data organization, we do what we call data aggregation. Sometimes data needs to be aggregated to a coarser level to analyze the patterns and also to analyze the trends in the data. Aggregation can involve summarizing data at a higher level. That is, you can do it if you collect it daily, you can summarize it monthly instead of daily, or combining categories to create a broader group. So data aggregation is very important. Another thing we do in data organization is data labeling. It is crucial to label variables and provide clear descriptions to ensure that the analysis is interpretable. Labels should be concise, informative, and consistent across all variables. So also when you're doing data analysis, we do that documentation. Maintaining proper documentation of data source, data collection method, variable definition, and any other transparency is vital for transparency, reproducibility, and future reference. And finally, data storage. When we are organizing data, we are simply just putting this data in a way that it can be stored easily. The organized data should be stored securely and backed up to prevent loss or corruption. And the appropriate filing we use in computers is CSV, and Excel. These are used to store our data so that when it comes to manipulating it or when it comes to analyzing it, it becomes so easy for us. Another way, now, those are ways in which we organize data, but there are good reasons why this data should be organized. There are good reasons why this data should be organized. What are some of the reasons why we organize data? One is for accuracy and reliability. Organizing data ensures its accuracy and reliability. And by cleaning and structuring the data properly, potential errors, outliers, or inconsistencies can be identified and be addressed. This improves the quality of the data and enhances the credibility of the statistical analysis and the finding. The second reason why we should organize data is for efficiency analysis, efficient analysis. Proper organization of data simplifies the analysis process. Well-organized data is easier to navigate, understand, and manipulate. It allows researchers and analysts to efficiently apply statistical techniques, perform calculations, extract meaningful insights from the data. This saves time and affords data exploration and analysis. Another reason why we should organize data is for the data interpretation. Organized data facilitate interpretation by structuring data in a logical manner with clear variable labels and descriptions. It becomes easier to understand the meaning and the context of each variable. This enables researchers and stakeholders to interpret results accurately and draw appropriate conclusions. And finally, why do we organize data? The importance of organizing data is for comparing and standardization, comparability and standardization. Organized data promotes comparability and standardization across different structures or datasets. Consistent data organization practices such as using standardized variables, names, formats, and units allow for easier integration and comparison of data from various sources. This enables researchers to conduct meta-analysis, replicate studies, combine dataset for more and comprehensive analysis. Having said this, the others, for example, data management and data visualization. For data visualization, well-organized data lends itself to effective data visualization by structuring data in a way that aligns with the visualization requirements. It becomes easier to create informative charts, graphs, and dashboards. Data visualization enhances data exploration, communication, and understanding, enabling stakeholders to grasp the complex patterns and trends more easily. Now, we are now going to look at how we can organize data. The following are scores collected by a researcher from a certain school. And when we look at them, they need to be organized. They are haphazard because when we are told to make meaning out of this data, it might be difficult. So we organize this data by constructing a tally table. We organize this data by constructing a tally table. And from the tally table, we can easily see the trends of the data, and we can easily see which number or which score has a higher frequency, just at a look from a snapshot. Because the data is organized the way it is, it's not organized, but we organize it. And we are now going to organize this data by looking at what is the highest value from this data, what is the lowest value from this data, and list this data either in ascending order, like we have done here. We've seen that the highest value is 95 and the lowest value is 84. So we have listed this data in ascending order, but we want now to tally it so that we see which value is appearing more frequently, which value is less represented. And by doing this, we will be organizing this data, and we can easily now start manipulating it for our statistical analysis. How do we proceed when we are tallying? We look at the values we have been given here, and we take a pen. I'm taking a red one. Now, when you have these values, the first value on our list is 86. So you cross out this value and you come to our data and you look for where 86 is and you tally it with that stroke. Then you go back. The second value is 95. You cross it out. Then you go back to your tally sheet and you look for where 95 is and you tally it with one stroke like that. Then you come back to our data. 92 is the next number. Then in our list, we have 92 there. We stroke it like that. Then we move on. 89 is our next number. Then we go on. 89 is here. We stroke it like that. We move on to the next number. We cross it out with 92. We come back and we are able to tally it like that. We have the next number is 92. We come back to our tally list. The number is there. We tally it like that. The next number in our list is 91. We cross it out. And when we come here, 91, we're able to tally it like that. We tally it with a sliding stroke. The next number in our list is 90. We come back to our tally. We look for where 90 is, and we tally it like that. We go back 88, and we come back to our list. 88 is there. We tally it like that. We go on again. It's 93. We cross it, and then we come back, and we're able to tally it. We move on again. Our next number is 92. We cross it, and then we come back and we tally it. We move on. The next number is 85. We cross it, and we come back, and we are able to tally it like that. We go back again. Our next number is 95. We cross it, and when we come back, 95 is there. We tally it. We move again. The next number is 84. We move back to our table, and we identify 84 there. We tally it. We able to move back again, and we have 88. So our next number, 88, is there. We tally it. So we move back to a number 93. We cross it, and we come back, we look for 93, and we are able to tally it like that. We go back to our numbers. The next number is 92. We cross it, and when we come back, 92, there are 4. So the 51, we cross it across. We cross it across. We don't tally it, we cross it across. If there are 4, so that we have a band of 5, 5, 5. So when we get to the 51, we don't tally it the way we are tallying the rest, but we cross it across. Now, when you have done this, you will get a table that looks like this one here. I organized it early for us so that we don't waste a lot of time tallying up to the end. And we realize that 84 is appearing 3 times. 85 is appearing only 1 time. 86 is appearing 7 times. 87 is appearing 3 times. 88 is appearing 9 times. 89 is appearing 8 times. 90 is appearing 9 times. 91 is appearing 12 times. 92 is appearing 18 times. We have 93 is appearing 13 times. 94 is appearing 10 times. And 95 is appearing 7 times. So this is what we call the frequencies. This is what we call the frequency. The number of time an item is appearing in a given data. So having done this, we now can represent this information on a table. Having collected data, one obvious method of displaying the data is in a table form. Like this table now can be able to make meaning. When somebody looks at this table, is able to see the trends in this table, and now can use this data to manipulate and also do the analysis and come out with his way of handling this data. So having the data itself, sometimes these values are too big. Like these values here, we have seen them. We might have so many values, and then one of the disadvantage of this big data is that it might become so hard for somebody to express this data in a good way. But there is what we call grouping of the data. We can group this data and have them condensed so that it can also be presented on a limited space. Because having a table, if you had so much data, it will not be easy for us to condense it. But sometimes we group data, and when we group it, it becomes easy for us to present it in a good way. And how do we proceed when you are grouping such a data? There is a process, there is a way in which we use to group this data. We first of all determine the interval for tallying the data, and these you follow the following steps. The first step is determine the range of the data. Range simply means the highest value and the lowest value, the difference from the highest value and the lowest value. So from our data, the highest value was 95 and the lowest value was 84. So the range will be 95 minus 84. So when you subtract this, you will get that our difference or our range will be 5. So the second step is to decide on the number of intervals or categories you want to create. This depends on the size of your data set and the level of detail you want in the frequency table. For example, let us choose an interval of 5, meaning that when we have a group of 5 in each data or in each interval, we have 5 items being represented in that group that we are going to group. Then the third step is to calculate the interval width. Divide the range of the data by the number of the intervals. For example, here, in this case, our range was 11, because when you take 95 minus 11, you get 11. And then because you want your intervals to be 5, then you divide by 5, and this one will give us approximately 2.2. Now round this value up to the nearest whole number to determine the interval width. Let us now round it to the whole number. Sometimes people say 2, but I want us to round it to 3. I want us to round it to 3. Then step 4, determine the starting point for the intervals. For example, in our data, the first number was 84, but we must choose a value that is slightly lower than the minimum value to ensure that the data set is captured. In this case, we choose 82 as the starting point. So if we choose 82 as the starting point, then step 5, we create the intervals by adding the interval width to the starting point successfully. For example, the interval will be as follows. 82 to 84. Remember, the interval width is 5 members. So we have 82, 83, 84. There are 3 in that width. There are 3 in that width because we calculate the width and we saw we are going to have 3 in each. We are going to have 3 numbers in each. So we have in this one 82, 83, 84. Then the next group will have 85, 86, 87. There are 3. Then the next week will have 88, 89, and 90. Then the next one will have 91, 92, and 93. And then finally we'll have 94, 95, and 96. Note that this interval extends beyond the maximum value because the maximum value in our case was 95. So this extends beyond the maximum value, but it ensures that all the data is captured. You can then use these intervals to create the tally or frequency table as mentioned in our previous or in our previous working. We were working and then we were able to create tallies. So in this case, you are able to have this and you are able to have your tallies. In these tallies now, you have, you look for these numbers so that we have frequency here or how many times is that number able to appear. So we have, okay, we have the first tally for 82 to 84, 85 to 87, 88 to 90, 90 to 93, then 90 to 94. I will leave this one for you to do it so that you can come up with tallies and see how many frequencies are going to be produced in this group data. Let me go over again to see that we are able to grasp what we are talking of in this place. To determine the interval for tallying the data, you can follow the following steps. 1, determine the range of the data. Find the maximum and minimum. And in our case, our minimum was 84 and our maximum was 95. So when you subtract, the range is actually the difference between the highest value and the lowest value in your data set. And this one will give us 11. Second step, decide on the number of intervals or categories you want to create. In this case, we're going to decide that we want 5 categories. We want 5 categories in our data. Now step number 3, now calculate the interval width by dividing the range of the data by you have, which is 11, by the intervals you want to have. In this case, it is 11, which is the range, all over 5, which is the intervals we have chosen. It will give us approximately 2.2. But a data set of 2, it's 2 members only or 2 items only is too big. So we round it off to the nearest number that we are comfortably handling. And this number is 3. This number we are comfortably handling is 3. Then we determine the starting point. So in this case, we choose 82 such that it is going to capture all the data sets that we have. Now we create our data sets by adding on numbers. So we have 82, 83, 84. That's the first category. So the second category will be 85, 86, 87. And you move on like that up to the last one. And I've said the last one is extends beyond the maximum value because it ensured the data, that all the data is captured. Thank you very much. We can now move on to another part of our data. This part of data is representing data graphically. This data, when presented graphically, will make statisticians or people or stakeholders who are looking at your data to have meaning. Because when you present data graphically, we are able to see clearly the trends and the patterns in the data. And many types of graphs or charts are used in statistics, depending on the nature of the data and the purpose of which the graph is intended. Among these, we have the bar charts, we have the pie charts, and we have the line graphs. Among these, when it comes to presenting the data graphically, among these graphs we use, we have the bar charts, the pie charts, and the line graphs. So I want us now to start off by seeing how we can be able to present manually our work on a bar graph. But later we will see how we can use computer softwares that can assist us come up with these graphs. The first one I'm going to consider is the bar graph. Bar graphs are the most common types of used in practice. A bar is a thick line whose width is shown merely for attention. So you can have a bar with a light line or width. Others you can have them with a very wide width. This is just for attention. The bar graph makes comparison by means of parallel bars of equal width placed either horizontally or vertically. The bars are preferred, the vertical bars are preferred because they give a better look and facilitate comparison. So we have two of them. The first one here is on our screen. This one I am calling it a vertical bar. A vertical bar. And you see, those bars are not touching each other. These bars are not touching each other. They are apart. And also we can have horizontal bars. From here on the screen, on my right hand, I'm having the horizontal, and on my left hand side, I'm having the vertical bars. And I've said that vertical bars are preferred because they give a better look and facilitate a better comparison. The gaps between one bar and another should be uniform throughout. These gaps here, you see this gap from bar 1 to bar 2. They are uniform. And when you go for bar 2 and 3, these gaps are uniform. These gaps are uniform. These gaps are uniform. They are equal in length or equal in width. Now, in bar graphs, what matters is the length. For example, from the horizontal scale up is what matters, but the width of the bar does not matter. So when you're having your bars, make sure that when it comes to the width is very important. The width is not very important, but the length is very important. We want to represent this data. We have here a number of tourists visiting a given town in a year. And these numbers are given for different years. We have So we want, sorry, I dropped my, let me bring back my screen. We want to represent this data given here on a bar graph. The table shows the number of tourists visiting Disneyland. And we want to represent this data here. And in organizing data, you can see one thing here, is that this data is represented as 15.1. But when you come to the narration here, we are being told these three zeros. These three zeros are actually telling us that this data being presented here is in thousands. So it means that what we have here is 15,100. This one is 20,500. So it's very important to know that we can represent this data in a way that we don't have to take a lot of space. Now, when you are drawing a bar graph, when we are drawing a bar graph, we have here the years, they are categorical. And one thing I should mention is that when you are presenting the data on a bar graph, we should present a categorical data, not continuous data. We don't represent continuous data on a bar graph. We only present categorical data. So when it comes to this categorical data, we have categorized these tourists in 1998, 1999, 2000, 2001, 2002. We are categorizing in years. We are not having continuous data here. Now, we have to choose a scale. We have the vertical scale and we have the horizontal scale. We have the vertical scale and we have the horizontal scale. Now, we come and have a uniform scale on the vertical scale, a uniform scale on the vertical scale, uniform scale on the vertical scale, uniform scale on the vertical scale. In fact, otherwise, this one should be divided uniformly. And we look at our data here. We see that the highest is 54.6 and the lowest is 15.1. So when you look at the highest being 15.1 and the lowest, so we should have our scale being able to accommodate all these values. So we will start with 0. Then this one should not be at that point. This one should be here because we're supposed to have a uniform scale. This one should be 10, 20, 30, 40, 50, then I'll have 60 there. Then I have 60 there. Now you see my scale is uniform. Then I'll come and look at the bar, the first year. The first year is 15.1. So I'll come and locate 15.1. 15.1 should be somewhere there, yeah? And I draw my bar in that manner. This is 1998. Then the second one will be 20.5. 20.5, I think there. And this bars should not be able to touch each other. So this is 1999. Then it's 31.8. So 31.8 somewhere there. So this is 2000. And make sure that you are able to label the axis. So this one is the year. And this one is the number of tourists in thousands. number of tourists in thousand. So at the end of the day, you'll have bus that looks like the ones I have here. At the end of the day, you'll have the bus that looks like one here. And I've said the scale should be uniform. The scale should be uniform. And the bars should not be able to touch each other because this is categorical data. It's not the continuous data. The other type of bar is what we call multiple bars. Now, multiple bars, these are type of budgets that is used when comparisons are made between more than one characteristics. Bars representing different characteristics are placed side by side. So we have two bars representing a given characteristics. For example, here we have characteristic 1, we have characteristic 2, but there are two bars representing that characteristics. We have characteristic 3, we have category 4, and we have category 5. And on this side, we have our scale being equal. On this side, we have our scale being equal intervals. So how do we proceed? We proceed the same way, the way we did it on the other from the previous example, but this time we should draw the two bars of the data or 3 bars for the data that is given. For example, there is a table here showing television licenses, those people who are watching, who have paid for the television, and we have those who have paid, who don't like watching television, they like watching for the cinema hall, their favorite movies at the cinema hall. So in the year 1999, there are numbers, but also I'm representing this data in thousands. I am not writing thousands in the main narration, but I have summarized, I was showing 3 zeros there, showing that this data is in thousands. This part of the data is only informing you that this data is in thousands. This data is in thousands. So in the year 1999, I have 14,000 having licenses for the television, and those who are going in for weekly admissions in the cinemas were 23,000. And we proceed up to 2000, 2001, 2002, 2003, and their numbers have been given here. So we proceed now to have this data being presented on a multiple bar graph. Also, we divide our scale uniformly. We divide our scale uniformly. We divide our scale uniformly. Probably using our ruler. We divide our scale uniformly. Then we look at our both the scales here. The highest is 26 and the lowest is 11. The highest 26 and the lowest is 11. So we go here and have 0 as our starting point. So we have 5, we have 10, we have 15, we have 20, we have 25, and 30. You can proceed, but 30 should be our last number. So we look at 1999. What were we having? We were having 14 licenses for TVs. So we have 14 somewhere there, closer to 15. We draw the first bar there. But now we want to represent this one by a different color. We take another different color to represent 23 as weekly admissions in cinemas. So it will be 23. 23 is somewhere there. Sorry, this one not coming well. So 23 is there. I'm using a different color to do the representation of this. So this one is being categorized data. This is which year? This is 1999. This is 1999. Then we move on again. Take my pen again, a red one. And we are going to go to the next year, which is 2000. We had 19. So 19 is somewhere there. 19 is somewhere there here. So I have the bar there. I have the bar here. And I look at 20.5. 20.5. I take again my pen and I'll draw 20.5. 20.5 somewhere there. Not very long. 20.5. That is it. So you move on up to the end. But when you finish, you are supposed to label your axis. This is the year. And this is the number of attendance in thousands or licenses in thousands. But one important thing, you must be able to come up with a legend to tell us what each of the bars represents. So, for example, this one will be the red one. The red one, you'll draw the legend here and tell us the red one, these are a TV. And also you have the green one here. You tell us that the green one, which have been struck, it's for the cinema. It's for the cinema. So you'll get something like this. You'll get something like this. Having your multiple paragraphs presented in this way. And it's wonderful to have it in this way. You have the year down there, and you have the number of thousands, and you have the year, and you have your legend, and you see the legend is up here, showing that this color represents this and that color. This is a multiple bar graph. Then we have the third type of the bars. We call it composite budgets. And this type of budgets that is used when we want to compare the same characteristics from different sources. In this case, a bar chart for the total is drawn and then broken down into components. Here I have some data. The data I have here is total earnings in US dollars, foreign exchange for exported agricultural commodities by a certain country. And these shows the export for coffee, tea, sisal, and pyrethrum. The total for year 2000 and 2000 is 167. The total for year 2001 is 82. The total for year 2002 is 207. The total for 2003 is 205. And finally, the total for 2004 is 236. So in order for us to draw this, we follow the same procedure. The same procedure, we come up with our totals, like I've come with the totals earnings. And with these total earnings, we are able now to represent them. Like for the year 2000, the total earnings were 167. So 167 is, but now we do the division in different, we put the division in different compartments. For example, we see by pyrethrum, we see sisal, tea, and coffee. We see all these being represented, like this one is for coffee. And for coffee, from our data, is 76. Is 76. And 76, you see, right? It's somewhere there. And if the one that follows, you add on from 76, you add on what you have for tea. 76 plus 59, you'll get a value closer to this one here. And then you divide it, this component so that you have your data in this manner. Finally, apart from bars, we have line graphs. A line graph is used to emphasize the changes in some characteristics occurring during an interval of time. So lines are plotted. Lines are plotted. And how do we proceed in having lines plotted? I have these data here, data showing the population of our country from 1880 to 2000. And it's a period, it's an interval of 10 years. An interval of 10 years. An interval of 10 years. We're showing this population in this country for an interval of 10 years. And we have this interval. So we can draw these intervals to show how this population is being affected. And this is how we proceed. We have our scale here. So we have a uniform scale on this side. A uniform scale on this side. We have a uniform scale on this side. So we have, let's put it there, again there, third there, fourth there, there, we go, uniform scale, uniform scale. Then on this uniform scale, we are supposed to look from our data. What are we having? So we are having the highest being 151 and the lowest at 4. So we're going to have 0 as our starting point. Then we have, let's use 10, 10, 10, 10. So we have 10, 20, 30, 40, 50, 60, 70, 80. Or if these scales go to somehow leave other values out, we can do away with it so that we can have a scale that is good to if this scale go to have values and some of the values are going to be left out, we can have another scale that is proper using 20, an interval of 20. So we can use an interval of 20. Can use an interval of 20. You see? So we have that one there. The scale should be uniform. The scale should be uniform. The scale should be uniform. And let us use the interval of 20. So we have 0, 20, 40, 60, 80, 100, 120, 140, 160, then 180. 180. So that you have now the years also having with intervals, same intervals, because this one is a line graph. You have the years with equal intervals. Years with equal intervals, or the attributes on this should be on equal intervals. So we have 1880, 1890, 1900, 1910, 1920, 1930, And you go on like that. So you will come and identify this value. 1888 was 34. So 1888 was 34, somewhere there. So you plot that value. In 1890, it was 42. So 1890, it was 42. You come and plot that value there. 1900 was 56. So you go and look for 56 somewhere there. And you, after plotting all the values, you join them with that straight line, and you'll get something like what I'm getting here. You'll get something like what I'm getting here. So this is a line graph. This line graph is able to show us the trends in the data, is able to show us the trends of what is happening in the data that has been collected. Just to look at a sample questionnaire, how we can code, identify the variables, and proceed to put this information in a software which can assist us in analyzing or organizing the data that we have. A question of a student of education policy and management did a survey and wanted to know how the policy in education is implemented. And here is a sample questionnaire which the student used. The questionnaire was in different sections, section 1 up to 6. And section 1 was looking for information from the respondents. And this information included the age of the respondent, the gender of the respondent, the highest level of education of the respondent, and the county in which the respondent reside, and finally, the occupation of the respondent. Now, having looked at this information, we can be able to identify the various variables that the researcher was looking for, and the variables as given by the respondents. In this case, question 1 was asking the age. Now, the variable here was the age, and the level at which this variable was measured was nominal. The second question was asking the respondent gender. Now, the variable is gender, and the level of measurement is nominal. Also, when you're looking at the highest level of education completed by the respondent, the variable here will be education, and the level of measurement will be ordinal. The county in which the respondent reside, the variable here, we are going to use the county, and the level of measurement is nominal. And the occupation of the respondents, the variable here will be the occupation, and the level of measurement will be nominal. So we have identified the different levels of measurements, which are very important when it comes to organizing and analyzing the data. The second part of the section of the questionnaire was understanding education planning and policy from the respondents. And respondents here were asked if they are familiar, and they were to respond yes or no. And the information sources where they get the information, either from government websites, news websites, social media, education data organization, and others. Now, when you look at this, when you are categorizing, when you're identifying the variables in this case, we go to get from the first question, are you familiar with education planning and policy? That variable we are looking for is familiarity, and the level of measurement will be nominal. And the second question, how stay informed about the information sources? The variable here is the information sources, and this variable is going to be measured at the nominal level. The third section of the questionnaire was on education policy evaluation. And on this, there were several questions that were asked. And after looking at this question, in your opinion, how effective is the current education planning and policy in achieving its intended goals? What are the areas of education planning and policy do you think need improvement? How do you rate the inclusiveness and equity in the current education planning and policy. Now, when you look at this, the first question was looking at effectiveness of the policy, and this policy is going to be measured at the level of ordinal. The second one is where each area that needs improvement. This one is going to be measured at nominal. And the third area is looking at inclusiveness. The variable is inclusiveness, and it's going to be measured also at ordinal. The fourth section of this questionnaire also had several questions, and it was looking at decision making. And these were the questions that were being asked here. Are you involved in a decision making process related to education planning and policy? Now, if yes, please describe your role and responsibility in the decision making process. These are the questions asked for the respondents. How transparent and participatory do you think the education planning and decision making process are in your country? Now, when it comes now to identifying the variable in this section, we have the first question was asking the respondent to know if they are part of involvement. And the variable being measured here is involvement, and the level of measurement is nominal. And the other part, if yes, so this one will be the textual, the role and the responsibility. The level of measurement will neither be nominal, ordinal, interval, ratio, but it will be the textual, because we will not be looking at a particular. We'll not just be looking at a particular, and we are going to come up with themes in this area. So in order for us to do the analysis of this part of the question, we will use the qualitative means of analyzing, and we will divide these themes in different categories. And finally, how transparent or participatory do you think the education planning decision-making process are in your country? The variable being measured here is transparency, and it's going to be measured at ordinal level, because we are going to order it. Then the fifth part of the questionnaire, looking at the financial resources allocation, decision making, and also we have about 3 questions in this area. And when you look at this question, how do you rate the allocation of financial resources? Then number 15, how do you think the current funding mechanisms in place is inadequate or not? And are there any specific areas within the education that you believe require more funding? So when you come to categorize this part of the questionnaire, you have to identify the variables that are going to be measured and at which level. Now, the table here shows us that the first question here was looking, the variable that it was being measured was the resource allocation. And we're looking at the level of measurement of resource allocation is ordinal. We are going to order it. Then the second part is funding mechanism, and this part is going to be measured at nominal level. And finally, the third part is look at the funding areas, and because we are not going to measure it at nominal, ordinal, interval, or ratio, we are going to look at qualitative nature, or those areas that are going to be put, and we are going to put it in various thematic areas so that it can be analyzed. We have the sixth part, education equality and teacher development. We have also other questions there we have put there for the respondents to be able to respond to them. How will you rate the overall quality of education in your country? Do you think there is need for professional development programs for teachers? And if yes, what specific areas of professional development do you believe are essential for teachers? Then when you put them in a table like I've done, you'll realize that the first part of the question is looking at the variable education quality, and it can be measured at ordinal level. The other part of the question that follows, looking at the professional development of teachers, and can be measured at the nominal level. And the final part of the question, which respondent might come up with different areas of different kinds of answers. We go to look at the qualitative nature of the textual qualitative nature of what the respondents have come up with, and we do thematic, we do things And from these themes, we can be able to analyze. So we are not analyzing it either on nominal, ordinal, interval, or ratio. Then come up with the data in order for us to fill. This, I have fictional data having been filled by about 40 respondents. And how can we now move with the fiction data to fill in a software so that this software can help us organize this data and even come up with a visual representation of this data, draw graphs, draw those visual representations so that we can be able to see how this data is presented. So I'm going to bring the Excel or the spreadsheet and see how we are going, because we have already identified at which level we are able, or which level we are able to represent this data on. So I have about 40 respondents. I have. So I have here the data. I have here the data for us to consider. I have the first question. And on this first question, I have the age of various representatives that I have given. And you can see the variable that is being measured here is the age, and we are measuring at nominal level. So this part is not necessary, not much necessary, this, but I've entered it in the cells. So as you can see, I can now have my photo respondent, and I can now move to organize this data. How am I able to organize this data? How am I able to count this data? Because I wonder the frequencies or the number of respondents that I've given as this data. Because I've seen the first respondent is 25 to 34 years. The second respondent is 35 to 44 years. The third respondent is 35 to 44 years. But counting might be one of the process of doing this. But when we move on, we can be able to use this Excel sheet to count for us the number, to count for us these respondents. How many are they? How many are they in each category? So we are going to have these categories here, and I want to bring these categories over to us here. I will put these categories here because I had how many categories? I had the category from 18 to 24. I had the category from 25 to 34. I had the category of 35 to 44. I had the category of 45 to 54, and I had the category of 5 years and above. Now, in order for me now to, or anybody using the Excel, able to count how many respondents are in this category of 18 to 24, 25 to 34, you have to use some inbuilt formulas to do that. So you put your cursor in an empty cell below that category, and you put equal sign, and you bring in the function of count if. You can just bring that count function by just typing count, and you'll see those functions coming. And I'm looking for this function of count if. So when that function comes, it will be able, it's looking for the range of the values from which you are going to select. So bring your cursor to all these values in that first cell and drag down up to the last level where you have all your data. Select all the data, and then you'll have selected your range of the values you want this function to look for. And then it's asking you which criteria are you going to use. Then put a comma sign, and you will be looking for the ranges of 18 to 24. So click above in that range there. 18 to 24. Then close that bracket and then hit enter. It will have counted, it automatically count for you the number of values that are from 18 to 24. There are 5 values. Then come to the second cell where we are having 25 to 34. Then put in equal sign. And after putting in equal sign, bring in or type in count. And when you type in count, it will bring a drop-down menu with several counts, but I want count if. So select count if. Then it will want you to select the range of values. Go back and select all these values again from 25 to 34 up to the last one. All the cells that are containing your values, that's the range you want, and then put a comma sign. Then the criteria will be to choose the 35 to 44 because you have put that that range above. So you select that cell above, and then you close your function there, and then you hit enter. Then there one. Then there I am. I got there. Then equal sign. Then count. Then it brings for me count if. I want that function of count if. Then I select the range of the values from the cells I'm having here. Then I'm able to get that. Then I want the criteria 55 and above. Then I close, and then there I am. I have all these values. I have finished. I know now that those who are 18 to 24 years are 5. Those who are 25 to 34 years are 9. Those who are 35 to 44 years are 8. Those who are 45 to 54 years are 8 also. And those who are 50 years and above are, those who are 50 years and above, are 55 years and above, are, those who are 55 years and above are 11. Then I want now, this is my frequency. This is what we are calling the frequency. The number of times each part is appearing. The number of times each part is appearing. Then I'll move to, I'll want to have the cumulative frequency. Let I write CF, the cumulative frequency. The cumulative frequency, the first cell is having 5. So I'll put 5. Then the second cell is having 9. So I'll take what I have in the first cell and add to what I'm having in the second cell. So I'll take 5 plus 9. So I'll have what I'm having in the first cell, which is 5, add on what I'm having in the second cell, which is 9, and I'll get 14. So 5 plus 9 is 14. That's the cumulative. We are adding the values cumulatively from the first cell to the last cell. So I'll move on to the second cell here, that cell there. Then I'll have what I have in the first cell, the second cell, because there's the sum of what I have from the first and second cell, which is 14. So I'll take 14 plus what I'm having the third cell. That one will give me 22. That is the cumulative frequency. Then I'll want to proceed with what I'm having the third cell. I add on what I'm having in the fourth cell. So I'm having 22 plus 8. That is 30. That is 30. Then finally, let me see, because that is 30. Then I'll move finally to the last part of my, data. I have what I have in the second last cell, and I add on what I'm having in my last cell. That will give me all the respondents that I was looking for. and that's the cumulative frequency. We can also move ahead and calculate the percentage represented in each part. So I'll have put a simple formula there, like I have 5 here, and my final my final cumulative frequency is 41. So I'll have 5 of the last one here, that is 0.2, but I want to give it in percentage form. So I will go to the percent up here on the up here, then that's 12%. Then I will move to the second cell. That's 9. There are 9%. There are 9 members there. Then the cumulative frequency, final one was 41. Then I have 21%. You can also calculate this one manually. I have 8 members in this category. Then I want to know which percent is this. So this percent is 20. Then I have 8 also here. Then divide by the final cumulative frequency. This one is also 20%. And finally, the final one is 11 or 40. Then I have my percentage here. My percent is 27%. Let me see if I can have adding it 1 decimal point. 1 decimal point will be good. So these percentages I have here, I've been able now to represent I've been able to organize my data. I have the frequencies, I have the cumulative frequency, I have the percentages like that, and we are able now to see how this data looks organized in the Excel sheet, looks organized in this part of the sheet. So I had already put all this data in the raw data from the questionnaire, and this how my data looks like. I have all the data. I've put all the data in a spreadsheet like this one, the one you are seeing on your screen, and you are able to see how I put the data for every respondent here, and there are about 40 respondents, and you can be able to see now how you can move on. It's the raw data, does not have any meaning, but I have put it in the Excel sheet. But now you can be able to organize it. Now on this other side, I was able to calculate the percentages. I have my frequencies. On this side, I have my percentages. And because I have this data now being represented here in this manner, I can be able now to come up with bar graphs. I can be able now to come up with all what I need, because what you need is only to put formulas in your data. And when you put these simple formulas in your data using the counting function, you can be able to count all the attributes being represented here. And now you can come and represent this data in a bar graph. And this is how I will proceed to represent this data in a bar graph. I can represent this data using the percentage, like what I'm having here. I can use the percentage to represent by selecting the percentage part. And I go to the insert. And when I go to the insert, there is an icon for recommended charts. So I will click on what is recommended charts there. Then there are several charts that comes there, and I want the pie chart. So this is the pie chart. I will select on it, and you can see, as you can see on your screen, it comes. So I want these pie charts, and then I click on OK. When I click on OK, this pie chart has come on my screen, and it's here. So I need to do some modification on these bar charts, because down here on the horizontal scale, you are seeing when my data came, it did not come with the bar chart came. It did not come here with the representation of the data, because here our data was categorized in years from 18 to 24, 25 to 34, 45 to 54, and 55 and above. So what I want to do, I want now to put that part of information here, because on the vertical side, or on the vertical side, what you are seeing are percentages, and these are the percentages we are having there. So what I'm going to do now, I'm going to right click on the bar graph, and there is a top-down menu that comes, and I want to select on the data. There is that part, select data. I want to select on the data. And when that part comes, it's what's very important. On the left side and on the right side. On the left side, you'll see there are percentages. But on the right side, there is an edit pattern. I'm going to hit, or I'm going to select on that pattern, on edit pattern. Then when I select it, there is a menu that comes that looks what I'm having here. So this menu simply is asking me, which part of the data do you want to include in your, which part of the data do you want to include in your bar graph? Then you will select this data you want to include. I want to include these categories, 18 to 24, 25 to 34, 35 to 44, and 45 to 54, and 55 and above. I've selected it. Then you hit OK. When you hit OK, now those, you'll see those categories coming there. Then you hit another OK there. When you hit it like that, you go back to your graph, and you will be able to see that all those categories now have been included in your bar graph. It's looking nice. It's looking okay. Now they are there, and you can now from this information, you'll see the highest bar, which is for 55 and above, followed by 25 and 34. So you can be able to visualize your data properly. You can be able to visualize your data properly, and you can be able now to conclude, or you can be able to say something about this data you are having, that those members from the data or from the respondents who are highly presented here are members who are 55 years and above. That's how we represent. I've only given only one attribute, but we can also have another one. We can also have another one. We can also have we can also have another part. Like I said, this data, I've had all these from the questionnaires we are looking at. We have all these data, like the second question, they were asking, the second question they were asking the respondents was, what's your gender? And here, the gender we had three options: male, female, and other. So I have already gone ahead and put in the formulas, and we are able to see here from what you're having here, the gender, the female, the male, the female, and others. So here, what we are having, we can now proceed to have a bar graph for the data we are having. So we are just going to select the percentages, because you have already calculated the percentages there from the data we are having. So we select the percentages, and then we go to insert, then we go to recommended charts. Then there, we want to have the bar graph there. Then also, or we select on the bar graph we want there, then we are able to tell the program that is okay, we have selected that one. Then we have here the kind of the graph that has come. But we, as I told you earlier, we still have trouble, because from this bar graph, it has given us the percentages on the, right, on the vertical side. As you can see, it has given the percentages there from 0 to 60. But on the horizontal scale, we have problem because it's just indicating 1, 2, 3. It is not giving us the specific category of the data we wanted. So we right-click on the pie chart, and we go to select the data. So when we select the data like we have done, as in this, we move to the right side. There is a button there, edit. We move there. Then we go to our data and select the part of the data we want to include. So I've selected male, female, and others, and I click OK. Then I click OK again. And when I go to my bar graph, that information, as you can see, it will be included in our bar graph, and we can see from the respondents, male are above 50%, the female are above 40%, but below 50%, and others are not more than 10%. And you can be able to interpret your data in that manner. So you can do all this to this data and look at every variable being represented here. We have education, we have the county, we have occupation, we have the familiarity, we have information sources, we have effectiveness, we have improvement areas, and we have inclusiveness. And try to come up with by inputting the formulas in Excel and try to come up with the frequencies that are. Now, this method seems to be very tedious, and it needs somebody who knows what he's doing, who knows a little bit of computing in order for him or her input this in our program. There is another program that comes with inbuilt formulas. And what you need to do, you just need to input the data, and that program is SPSS. SPSS. That is Statistical Package for Social Sciences. I will open my SPSS, and I'll be able to take you through the SPSS, how you can be able to put your data, and thereafter, how do you analyze, or how do you simply click to get your frequencies, and how simply you can click and get your charts. Because when you have such like data, like what I was showing you in the beginning, when you have such like data, you need to input it in the program. And after inputting in the program, you need now to have it analyzed, or you need to put it in these different frequencies. And it's tedious because after that, you need to input the formulas. And if you are not computer savvy, or if you are not somebody who has a little bit of knowledge of computing, it might be very difficult for you to come up with a program that will assist you in getting what you want actually as somebody who is doing and who is organizing your data. So in this case, I have open. I'm going to share my SPSS with us. Let me pull down. This is the SPSS program. It has also cells like Excel spreadsheet. It has the cells, but on this, you need to prepare the program in order for it to receive your data. And how do you proceed? Down here, on your left corner, down on your left corner, there are two patterns. The first pattern is called data view, and the other one is called variable view. We have two patterns down here. One is called data view, and another one is called variable view. So you have to, first of all, set this program SPSS and make it ready to receive your data. And in order for you to make ready to receive your data, you have to start with a variable view. When you click on variable view, you'll have you'll have something that looks like what I'm having on the screen, and you have name. You have columns here, one starting with the name, type with it, decimal, label, values, missing, columns, align, measure, and roll. So you have to input in these columns, like there are rows 1, 2, 3, 4. So we are going to input in the first row the type of the data, or explaining the program, the kind of the variables we have already prepared. We are going to input those variables here, so that when we start inputting the data, the variable will be ready, and the program will be ready to take those variables and be able to analyze them. So we start with the first cell there. The first cell there, we want to input the respondents, because we have about 40 respondents from our data. We have about 40 respondents because we had prepared our data and we saw that there were 40 respondents. So we want to put either the code of the questionnaire or the name of the respondent. So here, for my case, I put here respondent. So I'll type respondent, because I have 4 of them. So when I type respondent, when I go in the next cell, now this first row is pre-populated, or is populated automatically. But there are things here I have to change in order for this program, or in order for the program to be able to receive the kind of the data I'm having. So on the type here, because I'll be typing in the name, I'll not be typing in the value. If I were type in the values like the digits like 1, 2, 3, 4, 5, up to 10, I will tell it, let the type be numerical. So there are 3 dots here. On the 3 dots, I just click on the 3 dots. When you click on the 3 dots, there is a pull down menu, dialog box that comes. And this dialog box is very important. It comes with values on them. The first one is numeric. The second one is comma, dot, scientific notation, date, dollar, currency, a custom currency, the string, or restricted numeric. That's integer with leading zeros. Now here, I want this part of the shell, or when I'll be inputting, I want to type in a name. I don't want to do another thing. So when you want to type in a name, you tell the computer that this one is string. So you select the string. And how many characters will you want to type in? Now, I will want to type in respondent 1. That's a very long name. It has several characters. So I will say restrict this one to 20 characters. So I've changed automatically. It was 8 characters, but I've changed to 20 characters. And I will say, okay. I'll say, okay. Now, it's still asking so many other questions. The width is 20, decimal 0. Because it's string, we don't have to do so many other things. That's the only information we want. We move on to the second row and under the name. And here, we now want to put our first variable. Our first variable in our table, when you are showing the variable, was age. So I will type in here age. So I will type in here age. I'll type age. So when I go in the second tab, I go in the second cell, the type, when I click there, the automatic auto population But this age, do I want now to enter age, or I want to enter a coded part? There are two ways in which I can enter this variable age. I'll look at my information here, and I decide to code this part. And when I'm coding this part, I will say that there are several categories here. The first category is 18 to 24. The second category is 25 to 34, 35 to 44, 45 to 54, then 50 and above. I can say that let 18 to 24 be represented by a numeric 1. Then 25 to 34 be represented by 2. Then 35 to 44 be represented by 3, like that. Then I will go back to my, I will come here and I'll have to go to the column headed values. Then I click on it. I will leave the column headed type at numeric, and I'll go on the column headed values and click on it, and the 3 dots will come. I will click on the 3 dots. Then when the 3 dots come around, I will be able now, the pull down menu comes, or the dialog box comes. Then where they have written values, I'll write 1 values. And where they have written label, I will be able to type there 18 to 24. I'll be able to type there 18 to 24. Then I will come down here. There's a button, add. I will click on that button, add. So I have added that value in my dialog box down there. Then I go again, I type value 2. That value 2, I'll now type in 25 to 34. I'll type in the label 25 to 34. Then I add. Then I'll have my value 3. My value 3. Then I will type where the label is 35 to 44. Then I add. Then I go again. I tap in with the values 4. Then I add the values I have here. I type in 45 to 54. Then finally, I have my final value there. That is value 5. Then label it is 55 and above. And then I add it in. Then I say, okay, I have coded. That's what I'm calling coding. I have coded my age there. Then I'll be able now to go. I'll go now to my view, my data view. Down there, the left right corner, at the left corner down at the bottom, the left corner at the bottom, I go and click on the data there. So what is happening here, you will see that at the top part, the column is headed respondent. And this respondent is what I had typed in the data view. And the second column is headed age as my variable. is headed age as my variable. So what is going to happen here? You see, you'll have ended all these. You have ended all these. But one important thing at the variable view, you go to the measure. In class, we talked about measurement scale, and click on that part. That is a pull-down menu that comes and is asking you, what are you going to measure this age at? Are you measuring at nominal? Are you measuring at ordinal? Or you are measuring at scale? Scale combines two measuring scales, that is interval and ratio. But now, because we had said already that we are going to measure age at nominal, you just input there, click nominal, and then you'll have finished. Because when you are analyzing this data, it's very important that you recognize that when you input the measuring scale, we'll be able now to move on with this program to measure this at that particular point. Now, when you are now inputting like respondent 1 from our data, it's 25 to 34. So you write in here, we are inputting now the data. You write respondent 1, and then the age here, that respondent is 35 to 34. And remember that we said that 5 to 34, 35 respondent 1, I said, is 25 to 34. 25 to 34, we said it's 2. We coded it as 2. 35, we coded it as 2. So we don't write here 35, 34, we write 2. Then we go to respondent 2. We go to respondent 2. Now respondent 2, according to our data, is 35 to 44. 35 to 44 is 3. We got it as 3. So we don't put the age, but we put 3. Then we go to respondent 3. We got to respondent 3. Now respondent 3 is how old? Chose also 35 to 44. Chose 35 to 44. We don't input the category of the age the respondent chose. We input 3. Then we got in for respondent 4. We go in for respondent 4. And we look at what the respondent 4 chose. Respondent 4 chose 45 to 54. 45 to 54. According to our coding, it is the 4th. We put number 4. We put 4. Then we move on to respondent 5. We move on to respondent 5. Respondent 5 chose 55 and above, and 55 and above is 55 and above is 5. So this one you put 5, and we move on like that up to the last respondent. We move on choosing like that up to the last respondent, and we'll have put all the variables that we need to get. I had already input this data, and I want to open this data that I have already put in so that we'll be able to look at the data I already have. So that we can be able to look at the data I already have. This is the data I've already input for us in the class for us to be able to use. So you see, we have, although I've mixed my respondents, I have respondent 1 on age as chosen 2, Responded 10 has chosen 5, or responded 11 has chosen 5, responded 12 has chosen. I have jumbled because this is how these respondents were coming. This is how these respondents were coming in on my list, and that's why I was able to input them like that. And you can see that on the age, variable age, I have put in the numerical values. I have not put in the age. And on the gender, I've also coded that on the gender, when you come here, you'll see I coded the gender here. Okay, where's gender? Gender here, you can see I coded it. It is 1 is representing male, and 2 is female, and 3 equals to others. And also you can come to education. Education, I did coding pattern. Education also I did coding, and the coding I did is, can you see it here? 1, primary school certificate. 2, secondary school or high school certificate. 3, bachelor's degree. 4, master's degree. 5, doctorate or a PhD, and 6 others which the respondent was supposed to specify. So you see, I've done some coding for others, and the measurement scales you can see for each one. I've chosen the proper measurement scale we are supposed to have. We have nominal or nominal, for the education. We said that we are going to measure at ordinal. And after finishing that, you can see we have been able to input the data for the 40 respondents that we are having. Now, I want us now to move and see how can this program be able to draw for us the frequency tables. We saw previously from the Excel spreadsheets, we were to input formulas. But in this program, we don't need to input formulas. The formulas are there already input for us. The only thing we need to do is to put the data in the program, and the rest we just leave for the program to analyze for us. For example, I want us to get the frequency tables for age. Frequency tables for age, because we have already input our data. When we go to analyze, there is a drop-down menu that comes with so many things. When we click on it, there is a drop-down menu that comes with so many things: reports, descriptive statistic, tables, compare means, general linear models, generalized linear models, up to the last one there. But we want the descriptive statistics. The descriptive statistics, we go to descriptive statistics. When we put our cursor on it, then there is another drop-down menu that comes, that is frequencies, descriptives, explore crosstabs, racial P and P plots, Q and Q plots. But we are looking for the frequencies, so we tap on the frequencies. When you tap on the frequencies, there is a dialog box that comes. And on this dialog box, your variables are there on that dialog box. Your variables are in the dialog box. So what you could do, you look at the variable you want. So we want our variable age. So we click on it, and there's a tap in the middle here. There's a tap in the middle here with an arrow. So we click on that tap to transfer that variable from the general list to the variable we want to analyze. And because we want these frequency tables to come, we don't want any other thing. We want the frequency tables for the first time. So what we are going to do, we have a dialog or a pattern, the dialog box there, down there in the left bottom corner, asking us display frequency table. So we have to check that box. We have to check this box. When you check that box is when your frequency table will appear, and then say okay. When you see okay, when you say okay, there is this box. There is this that comes. And when you look at it, it is a beautiful work that comes on. This beautiful works that comes on, it's having our edges arranged. 18 to 24, they are 5. 25 to 34, they are 7. 35 to 44, they are 9. 45 to 56 to 54, they are 8. 55 and above, they are, and they are all totaling to 40. Then there are percentages already calculated for us. For the first group, there is 12.5. For the second group, they are 70.5. For the third group, they are 22.5. For the fourth group, they are 20.5. And finally, the last group, they are 25.5. Also, when you look, we have the cumulative percentage having been calculated for us. So this program also tells us that they are 40 values that were input, and that's calling 40 valid ones, and there are 0 missing, meaning that we are not missing any. So in this, we are able to see this one properly. It's able to bring these values for us. It's able to display the values for us. Then we can just right click on the table, then we copy, and we'll be able to take it onto our work. We'll be able to take it to our work. Like if you want to put it in Excel, you want to put it in Word, you want to put it in whatever document you are working on. Whatever document you're working on, it will be very good. This is the data. This is the data I'm working on. Please, I'm very sorry. I realized that the window didn't upload this data for us. This is the data I'm working on. This is the data I'm working on. I'm very sorry. This data, I realized that my screen frozen when I had chosen this data. It was not displaying this data, but this is the data I'm working on, and I'm saying that I'll go back a little bit. That we have our variable view, and there are several variables. We have variable age, we have the variable gender, we have the variable education, we have the variable county, we have the variable occupation. Those are the only 3 variables that I was able to input in our data. These are the only 3 variables I'm able to put at the moment. They are I can put up all of them for demonstration purposes. I have put only these variables. And as I said, this variable age, I'm using numeric. The variable gender, I'm using numeric. The variable education, I'm using numeric. The variable county of residence, I'm using string because I want to type in words. And the variable occupation, I'm using string also because I want to type in words. Also, when it comes now to variable age, I have coded it. I am using codes. And these codes I'm using, we have them being displayed here. We have the codes being displayed here, like I said, the category of 18 to 24, I'm using 1. 2 we are using for the category of 25 to 34. 3, the category of 35 to 44. 4, the category of 45 to 54. 5, the category of 55 and above. Now, also, gender, we are also coding it, and this is how we are coding it. We are coding this in this manner. The category of male, we have put the value 1. For female, we have put the value 2. And for others, we have put the value 3. That's how we have coded it. Then for education, we have also coded it. And this is how we are coding it. I want us to see, all of us, how we are being able to code it. 1 is for primary school certificate. 2 is for secondary school or high school certificate. 3 is for bachelor's degree. 4 is for master's degree. 5 is for doctorate, PhD. And 6 is for others. And for county, I'm not coding, I'm using string. And for occupation, I'm not coding, I'm using string. And for education, the scale of measurement is ordinal. And for the gender, the scale of measurement is. You can see on the measurement here, there are scales you have to choose, because when you'll be analyzing data and you're not choosing these scales properly, then you'll have trouble, you have problems. Then you go to our data view, you'll be able now to see these respondents, or respondent number 1, I put 2, respondent number 10, I put 5, respondent number 11, I put 5, respondent number 12, I put 3, respondent number 13, I put 5, like that, up to the last respondent with the 4th respondent. Then gender, I've also done the same thing, and also education, I've said the same thing. I'm not using the string, I'm typing in the values that we coded. With the county, I've typed in Bungoma or Singishu, Turkana, like that, because I didn't code it. And with occupation, we have teacher, engineer, nurse, accountant, farmer. These are words I'm typing in, and that's how I'm able to use string. Now, when it comes now to representing this data on having frequencies, because we need to have the frequencies, and these frequencies are going to help us organize this data, because we have just input this data. We don't have, the data is not organized, it's still unorganized. We have only put it in a program which will help us now organize it. We go to analyze. Analyze is up here. And when we click on analyze, there is a drop-down menu that comes. And there are so many things here on this drop-down menu that has come. We have reports, descriptive statistics, we have labels, we have compare means, up to the last one. Now, we go to the descriptive statistics. And when we put our cursor on it, we realize that there are so many others that come: frequencies, descriptive statistics, explorer, cross-tabs ratio, P&P plots, and Q&Q plots. But we are concerned with the frequencies. So you click on the frequencies, and here there is a dialog box that will come. This dialog box, on the right side, it's an empty box. And on the left side, there is a box with variables that you input in your program. So we want to transfer the variable of interest, the variable which you want this program to draw for us, the frequency tables, and these from these variable lists, we have to look at it. And for us, we are going to choose age. So we highlight on age, and in the middle, there is an arrow showing us that we can be able to transfer the variable we highlighted. So we click on that arrow, and the variable will be transferred from the left box to the right box. And as we can see, our variable age has been transferred. So we don't want to do so many other statistics on this. We only want for this program to give us the frequency tables. We want this program to give us the frequency table. So we, at the bottom right, at the bottom left corner, there is a box there, which is asking us whether we have to display the frequency tables. We have to check on this box. When we check that box, we'll be allowing the program to draw for us those frequencies. Then we say, okay. So when we say, okay, there is a dialog box that is going to come, as I showed earlier. There is another dialog box that is going to come, as I showed earlier. And in this dialog box, it's there. I've put on our table. I've put on our screen. It's there. It's able now as drawn for us the various categories we are having on the age. We have 18 to 24. There's 5. The frequency is 5. 25 to 34, the frequency is 7. 35 to 44, the frequency is 9. 45 to 44, the frequency is 8. And 55 to 44, the frequency is 11, as you can be able to see. Now, also on this program, we can also be able to tell the program to draw for us the bar graphs. So we just go to analyze, and we move to descriptive statistics, frequencies. Then when we click on it, on the left side of the graph, you have seen patterns there. There is a pattern for statistics, charts, format, and bootstrap. So we just click on the pattern for charts, and there is a dialog box that comes. And this dialog box is asking us, which type of graphs do you want? Do you want a bar chart, a pie chart, or a histogram? And I will tell the program that I need a pie chart. I need a pie chart. Then I click on continue down there, and then OK. So when you just click on that, you'll give it some minutes. Give it some minute to process. You give it some minutes to process. And after it has processed, it will bring you a bar chart that looks like the one we are having on our screen. You see, it has told you the frequencies are on the vertical side, and the age category is on the horizontal side, and 18 to 24 you can see, and you can be able to tell from the pattern which area, which part is being having more respondents. Thank you very much for having listened to this lecture today. We will meet in the next lecture.